So here's the problem. A 22 ml solution of 0.4 molar RbOH requires a certain volume of second HCl solution to neutralize it. However, if 2 times this certain volume is added, the final pH is 1.149. What is this certain volume, and what was the initial HCl solution molarity? So I'm starting by just highlighting all of the key information here. And it's very important to recognize that since RbOH only contains one hydroxide, it's essentially equivalent to 0.4 molar of OH minus. And we'll see the same thing for HCl. Each HCl only has one H, so 1 molar HCl is equivalent to 1 molar of protons. So the first step in a problem like this that's got a lot of information is to clearly define all of the variables that we'll be using throughout the problem, both the ones that we already know and ones that we don't know yet. And to be as detailed as possible, we're going to specify the time, so whether it's an initial or a final value, and the compound that each quantity is describing. So first, the initial molarity of hydroxide is going to be 0.4. The initial volume of hydroxide is 22 milliliters or 0.022 liters, just to make the units easier. The initial molarity of H plus is something that we're solving for, so that's a question mark, as is H plus's initial volume. And we're also given that the final pH of the whole thing is 1.149, and from that, we should be able to pretty easily calculate the final molarity of H+. Step 2, let's gather all of the simple information first. So what I mean by that is let's quickly find any of the unknowns that we can without doing too much thinking or math. In this case, what that means is we can easily calculate the final molarity of H+ using that final pH with the simple formula of concentration of H+ equals 10 to the negative pH, or 10 to the negative 1.149, which gives us a final H+ molarity of 0.07096. And a key note here is to try to keep as many sig figs as possible in order to avoid losing data. And then just for clarity's sake, that symbol with the brackets is the same thing as big M of H+ final. Step 3. Now, to resolve the last bits of our information, it's often going to be very useful to create equations or an equation that describe what's going on in this system. This will allow us to relate the variables together and potentially form a system of equations that we can use to solve for both of our two unknowns, because two unknowns requires two equations to solve. So first, this equation relates the initial molarity and volume of H+, or the moles of H+, to our final molarity and volume of H+. This equation expresses the fact that the initial moles of H+ is equivalent to the moles of hydroxide that it neutralized plus whatever is left over at the end, which is that MHF times V total term. Our second equation just describes the neutralization. So the molarity of H+ initial times half of the volume added, because again, we added twice the needed volume to neutralize, is equal to the moles of OH minus, or the molarity times volume of OH minus. So let's go through these equations and figure out what we currently know and what we currently don't know. And of course, just to note, the total volume can be expressed as the volume of hydroxide initial plus the volume of H+ initial. So I'll check off everything that we already know with a green check mark. And we'll see that even though there are a lot of variables here, many of them repeat, and we also already know what many of them are. And then this purple circle and the orange circle are going to be for quantities that we still don't know. And it seems like there's 4, but actually it's only 2 because the variables are repeated. And this is wonderful because we have 2 unknowns, the molarity and initial volume of H+, but we have 2 equations, which lets us create a system of equations that we can use to solve for both of them. Step 4, where we will substitute into our system in order to solve for both quantities. So I'm just copying the equations out again here. And to get rid of that 1/2, we can multiply the whole thing by 2. It'll stay equivalent. And now we're going to isolate one of the unknowns that we want to substitute for. So rearrange the equation, we get this. The initial molarity of H+ equals 2 times the initial molarity of hydroxide times volume of hydroxide divided by the volume of H+. And then we can substitute that back into our first equation, which will conveniently actually allow us to cross out the volume of H+ initial, leaving us with only one unknown, which is over there on the right side of the equation, that volume of H+ initial. Now we'll rearrange the equation in order to solve for our current unknown, which is that, again, that VH+ initial. So just to define what's going on here, that first term in green is the initial moles of H+ that we added, which is double the amount of hydroxide because we added double the amount required to neutralize. The final term is the amount of initial hydroxide that we had in the solution. And that term in the middle is going to just help us correct for the volume change that happened when we added the HCl solution to the RBOH solution. We can get to our last step here, which is just substituting in the values that we already know to solve for the initial volume of H+. And once we do that, we see that the initial volume of H+ added is 0.102 liters or 102 milliliters. And again, H+ here is equivalent to HCl because they're in a 1-to-1 molar ratio. Now, to get our last unknown, we can just solve for the molarity of H+ initial, and we can use either equation for that, but I'm going to use our second equation. We can rearrange it and substitute to get the initial molarity of H+ was 0.173 molar. Okay, that's all for this one. If you have any questions, please drop them in the comments below. Subscribe. If you like the way I teach, I offer private one-on-one tutoring, which you can find via the video description or my website. Thank you very much.